Welcome to the National Oceanic and Atmospheric Administration in Boulder, Colorado. My name is Craig. I'm a meteorologist with Ceres working at NOAA Boulder, and I'll be guiding you on this tour. NOAA has been in Boulder since it was created in 1970, though our current building is newer. It was finished in 1998. Over 800 people work in this building in Boulder.
Is Boulder the only city with a NOAA building?
NOAA has other large buildings with many other workers in places like Washington, D.C., Seattle, and Norman, Oklahoma. NOAA also has many small offices all over the country. In this video, I will tell you about some of the work NOAA does in Boulder, Colorado. Let's start with the National Weather Service. The National Weather Service is part of NOAA. The National Weather Service forecasts the weather for every part of the United States, including all 50 states and U.S. territories.
How do the scientists know what the weather will be in different parts of the United States?
They know by having weather forecasters, or meteorologists, stationed all over the country. There are 122 forecasting offices in the National Weather Service. Each office just forecasts for the area around it. That means the forecasters that forecast for you know all about the weather patterns in your area.
Who forecasts the weather in Colorado?
We actually have 4 offices that forecast the weather in Colorado. The office in Goodland, Kansas forecasts for part of eastern Colorado. There are also offices in Pueblo, Colorado, and Grand Junction, Colorado. Inside our building in Boulder is an office that forecasts for the area around Boulder, Colorado. They forecast up in the mountains in places like Breckenridge and Estes Park. They forecast for the cities of Fort Collins, Boulder, Denver, and all around Denver. They also forecast for part of the Eastern Plains.
Do forecasters have to work all day long?
The forecasting office is always open. There are forecasters working every hour of the day, every day of the year. That means there is always someone to warn about tornadoes, thunderstorms, floods, and other dangerous conditions that can happen suddenly. Each forecaster only works 9 hours at a time, and they take turns working during the day and working at night.
How do forecasters see the weather outside?
They use many tools. They know the temperature, air pressure, humidity, and wind speed by looking at instruments called a thermometer, barometer, hydrometer, and anemometer. These instruments are placed all over the United States. We can also measure temperature, air pressure, humidity, and wind speed high up in the atmosphere with a weather balloon. A weather balloon is released twice a day in 92 places around the United States, all at the exact same time. In fact, there are hundreds of weather balloons released all over the world at the same time, twice a day. Forecasters also look at clouds using satellites. They can see where clouds are moving and which clouds will become storms. Radar is very important. Radar provides an inside view of storms, allowing forecasters to predict hail, tornadoes, and heavy snow. When forecasters need observations from people, they can call on many weather spotters in our region. Weather spotters are volunteers who have taken the free training from their local weather service office to provide safe, accurate weather information.
How do forecasters know the future?
Forecasters learn a lot about weather patterns, so they know when wind is most likely to move faster, when storms will probably start, and when it will become warmer or colder. They also get help from supercomputers. These are huge computers that are very powerful. The computers get information about the weather from weather balloons and satellites. The computers tell forecasters a prediction called a weather model. Forecasters look at many different weather models.
Who do forecasters talk to?
Forecasters spend a lot of time communicating with government agencies and private companies affected by weather conditions. They regularly coordinate with large and small airports, the Colorado Department of Transportation, regional emergency management, and local media, including TV weathermen. You can see forecasts for northeastern Colorado at weather.gov/BOU. For other locations in the United States, go to weather.gov and type in the zip code or city and state. Now, let's go find out about space weather at the Space Weather Prediction Center. The NOAA building in Boulder actually has 2 offices of the National Weather Service. The first office is the one that predicts weather for part of Colorado. The other office is a special one called the Space Weather Prediction Center, or SWPC. This office also has forecasters. They predict space weather for all of the United States.
Do space weather forecasters also work all day?
Yes, the Space Weather Prediction Center is also open every hour of the day and every day of the year. The forecasters just work part of the day and take turns working days or nights.
What is space weather?
Space weather events all come from the sun. There are many types of space weather events. However, 3 space weather related storms are the most important to look out for: solar flares, geomagnetic storms, and radiation storms. Strong magnetic fields may reveal themselves visibly as sunspots. When these magnetic fields become too stressed, they may instantly reconnect into less stressful alignments that cause sudden bursts of enormous amounts of electromagnetic energy known as solar flares. Geomagnetic storms are disturbances in Earth's magnetic field, usually caused by dramatic changes in the amount of particles and plasma coming from the sun, called the solar wind. The more intense geomagnetic storms are usually a result of explosive releases of billions of tons of solar material into space, called a coronal mass ejection, or CME. CMEs can reach Earth in as quick as 18 hours, but they usually arrive in 2 to 4 days. Radiation storms may take place when highly energetic protons suddenly move very fast along magnetic field lines stretching out from the sun into space. These storms happen in association with solar flares and CMEs, and can reach Earth in about 20 minutes.
Are space weather events always happening?
Space weather events can happen at any time, but sometimes they are more likely to happen. There are times when the sun's magnetic field is more chaotic, more likely to bend, twist, and break apart. At these times, we see more space weather events. There are also times when the sun's magnetic field is more stable, and we do not see as many space weather events. This cycle between a lot of activity and less activity is called the solar cycle. It is about 11 years in length.
Is space weather dangerous?
Most of us never notice space weather events because we are very well protected by our atmosphere and magnetosphere. The biggest health worry in a space weather event is for astronauts during a radiation storm. Luckily, astronauts can protect themselves when they get a warning from forecasters.
So why does SWPC forecast space weather?
Because these types of space weather storms may impact our navigation technologies, radio communication, satellites, aviation and spaceflight, and potentially the electric power grid. Here are some examples. GPS can become less accurate. Satellites can be bombarded with ions and electronics, leading to potential trouble. Certain radio bands can experience blackout conditions, making communication difficult or impossible for pilots and emergency workers. Even the power grid could become overwhelmed due to a sudden increase in current caused by the rare, most extreme geomagnetic storms. However, with warnings from SWPC, the people affected by space weather can be prepared, and they will have less problems.
Who do forecasters talk to?
SWPC forecasters talk to NASA, the FAA, people who operate satellites, FEMA, power companies all over the United States, space weather forecasters from other countries, and sometimes even pigeon racers.
Can we see space weather?
There is one way you might see space weather in action. That is by the appearance of the aurora, the dancing, shimmering curtains of light in the night sky. The aurora appears when geomagnetic storms are strong. These lights are most visible at night near the poles, and can happen when solar particles interact with gases in our atmosphere in just the right way. You can learn more about space weather and see forecasts at spaceweather.gov. Now I'll take you on to see a little bit about the climate work that we do through the Global Monitoring Laboratory. The Global Monitoring Laboratory, also called GML, is one of the Earth System Research Laboratories at NOAA Boulder. GML conducts research in Boulder and all over the world. The research of GML is in three main areas. First, tracking greenhouse gases around the world. Second, understanding how radiation from the sun is absorbed by the Earth's surface, as well as the role of clouds and aerosols in the atmosphere. Third, tracking and guiding the recovery of ozone high in the atmosphere.
How do scientists measure greenhouse gases?
Samples are collected in a few different ways. First, samples are collected by NOAA researchers 24 hours a day at GML's 4 observatories. In the Arctic Circle in Utqiagvik, formerly Barrow, Alaska, north of the equator in Mauna Loa, Hawaii, south of the equator in American Samoa, and at the South Pole in Antarctica. Second, samples are collected using aircraft and tall towers by NOAA researchers and partners we work with. Third, atmospheric samples are collected using a portable air sampling unit. The portable sampling unit is the size of a suitcase, containing glass flasks that volunteers worldwide fill with an air sample. The air samples are then sent back to Boulder and analyzed at the GML laboratory. GML takes and receives over 20,000 air samples every year. Another way GML scientists measure gases in the atmosphere is with an air core. The air core is a really, really long tube that is coiled up inside a styrofoam case. The air core goes up in the atmosphere with a weather balloon all the way to 85,000 feet. 2 are launched at the same time, so scientists can make sure they gather the same information. After the balloon pops, the air core falls down, collecting air all the way down.
What do scientists measure in air samples?
GML researchers measure carbon dioxide, methane, and approximately 65 other atmospheric gases worldwide. It's important to measure gases in the atmosphere frequently all around the world because the amount of carbon dioxide and other gases is different in different locations around the world and also changes with season during the year.
How long has the GML measured gases in the atmosphere?
Measuring carbon dioxide in the atmosphere actually started before NOAA, in 1958 in Mauna Loa, Hawaii. GML has now taken over this work and expanded the number of locations around the world measurements are taken.
Why does the GML measure ozone high in the atmosphere?
In 1985, scientists discovered the ozone hole over Antarctica. An ozone hole is an area where there is much less ozone in the atmosphere. Ozone high in the atmosphere is important because it reflects solar radiation. Less ozone means more solar radiation will come through the atmosphere. Scientists figured out that the ozone hole was developing because of certain types of gases used in aerosol propellants and cooling devices such as refrigerators. In 1987, these gases, called chlorofluorocarbons, were banned in a worldwide agreement called the Montreal Protocol.
How is ozone measured?
Researchers use an instrument called an ozone sonde to measure ozone in the atmosphere. Weather balloons with the ozone sondes attached are launched near Boulder and from the 4 observatories to take ozone measurements. The balloons reach a height of about 100,000 feet before they pop and then fall back to the ground with a parachute. Data is sent back to NOAA using a radio antenna. The Global Monitoring Laboratory's mission has always been to provide high-quality, long-term records of the atmospheric composition to understand climate change better. You can learn more about this research at gml.noaa.gov. Here's our last stop, the Science on a Sphere Theater. Science on a Sphere in the David Hines Planet Theater is a highlight for all visitors to NOAA Boulder. SOS was invented by a NOAA Boulder scientist. It is a 6-foot white sphere surrounded by 4 projectors to create an animated Earth.
How does science on a sphere work?
A presenter uses a remote to tell the computers what to show on the sphere. Our computers have a library of over 600 datasets, including 99 movies and 45 real-time datasets. So you can watch as hurricanes develop, or watch snow conditions in real time. Datasets show something about space, air, land, snow and ice, or water. The computers send the images to our projectors, and you can see it on the sphere.
Where is science on a sphere?
Besides our building in Boulder, it is installed in over 175 locations around the world.
Can I only see datasets on the big sphere?
There are 2 other versions of Science on a Sphere. There is a flat-screen version called SOS Explorer that is easy to install. The SOS team also recently developed a mobile version called SOS Explorer Mobile. It is free to download and is in the Apple and Android app stores. Let's take a closer look at a few of the datasets on SOS Explorer Mobile. When you launch the app, you first see blue marble with real-time clouds.
What does real-time mean?
Real-time means that datasets changes every day with new images from satellites. Look, you can see different colors in the ocean, showing where the ocean is deeper and where it is shallower. You can also see topography, which means you can see where mountains are. On the other side of the world, you see nighttime lights when the Earth is dark.
Where do these pictures come from?
We get images from satellites. Here you can see a lot of the satellites that surround Earth. We can take away all the satellites except the ones NOAA operates. Here are NOAA's satellites. There are 2 kinds. We have polar orbiting satellites that are close to Earth, and we have geostationary satellites called GOES, which are much further away. One way NOAA uses satellites is to observe clouds. Here you see clouds with radar on top to show rain and snow. Satellites can also tell us about temperatures on Earth. Here is the temperature on the ocean surface. You can see how warm the ocean is around the equator with direct sunlight, and how cold the poles are where there is less direct sunlight.
What else can we see on satellites?
Satellites can show us so much. Here's one more example. Using satellites, we can see change in Arctic sea ice over many years. Here we show ice in just September from 1979 all the way to last September. September is when there is the smallest amount of ice in the Arctic, but you can see that not every September looks the same. We have many more datasets you can check out at home, and we hope you can someday visit the NOAA Boulder SOS Theater in person. To learn more, go to sos.noaa.gov. Thank you for taking this tour with me today. I know we've already learned a lot, but we've barely scratched the surface on everything we do here at NOAA. Whether you are interested in studying the ocean floor with our scientists in the National Centers of Environmental Information, want to figure out what is in our air with the chemist in the Chemical Sciences Laboratory, are curious about why sea level is always changing with our National Geodetic Survey team, or want to learn about drought with the Physical Sciences Laboratory, NOAA Boulder has it all, and so much more. Take a look around our outreach pages to learn more about all we have to offer. Have a good day and stay curious.